Hi, welcome to the first part of the video series about vertical projectile motion. In this video, we will do introduction to the topic and learn some definitions. Imagine two objects at the same height from the ground level. One of these objects is a piece of paper and the other one is a stamp. In case that both released at the same time, stamp will fall to the ground much faster than the piece of paper. We can assume that the stamp falls faster because it is much heavier than the piece of paper. Let's compare the falling times for two pieces of paper, but one of them is crumpled. Even though they have the same mass, the piece of paper on the left still takes its time to fall. In a third experiment, let's place these two pieces of paper into a container with no air inside it. Both objects fall at the same time and acceleration. In the previous two experiments, objects were experiencing two types of force of gravity and force of air friction. In the last example, as there is no air, the only force experienced by the objects is the force of gravity. A motion where the only force acting on the object is the force of gravity is called free fall, and the object which is falling freely is called a projectile. According to the second law of motion, the net force applied on an object is equal to mass times acceleration. During free fall, the net force is equal to force of gravity. It is the only force acting on the object. Force of gravity can be calculated as m times g, mass times gravitational acceleration. We can simplify the masses in the equation. In conclusion, we can say that all free-falling bodies have the same acceleration due to gravity. The magnitude of the acceleration during free fall is 9.8 meters per second square, and its direction is always downwards, towards the center of the planet. This last statement will be very important in the next lessons, so let's repeat it again. The magnitude of the acceleration during free fall is 9.8 meters per second square, and its direction is always downwards, towards the center of the planet. In the next video, we will see the equations we use in this topic. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.